Hi guys, now let's have a look at the first question of the practice set 1. The given problem statement is, given a number n, if we can select any number between 2 and n, both inclusive, we should prime the probability that the given selected number is prime, and we should express the total probability as an irreducible fraction. So, what is probability first? So, probability is the probability equal to total number of successful outcomes by total number of outcomes. So here what is success? Here success is that the selected number is prime, and what is the total number of events, that is the total number. So the total number is any number between 2 and n, the total number of numbers between 2 and n. So success equal to number of primes, whereas total equal to numbers between 2 and n. So what are the numbers between 2 and n? The total number of numbers between 2 and n equal to n minus 2 plus 1. So this equation gives the total number of numbers between a given number and 2, both included. Okay, so next, what is an irreducible fraction? That is, if we are given a fraction like 4 by 6, we can further simplify it by dividing with 2 with the both numerator and denominator 2 by 3, which cannot be further reduced. So a irreducible fraction is that which can be further converted into a similar form. So our aim is to give an output of irreducible fraction. So what's our aim in writing the logic? So first we should find the total number of prime numbers. Later we should find the total number of numbers. Later we should convert the fraction probability into irreducible. Okay, let's go for coding. So here we are taking a number and we are taking input of a number. So we should find all the prime numbers between a 2 and n. So for we are taking a loop of starting from 2 to n. And we should find what is the prime number which has only 2 factors, that is the number, and number itself is called a prime number. And so we'll check out the factors starting from 1 to the number itself. So if what is the factor? A factor is that which can divide a number. So if I percent I modulo j equal to 0, that is the number can be divided by other. So we'll increase the number of factors. Number of factors is flag. So this will check out all the number of factors for a given number which is given by this loop, that is I. So if what is the prime number we said? We said that a prime number is that which has only 2 factors. So if number of factors equal to 2, we should increment the number of primes. Initially we are taking number of primes to be 0. So we increment the number of primes. Okay, so now we end up, after this code, we end up with the number of primes. So how to calculate next? Our next task is to calculate the total number of numbers between 2 and n. So total equal to n minus 2 plus 1. So now we got the NP and we got the total. All we have to do is represent it as an irreducible fraction. So as we said, to convert a fraction to irreducible, we should divide both the numerator and denominator by both the common factors. So let's we'll find all the common factors from it, starting from the dividers half to 1. Sorry. Okay, so now we'll check if this number, if a factor divides both the numerator and the denominator. So let's go. So if how do we know it's divides? So the modulo of the number with I should give 0. So if NP modulo I equal to 0 and total modulo I equal to 0, which means that an I can divide both in number of primes and total. So it's a common factor for both. Then we need to divide both the numbers by I. So now we have reduced it to the irreducible form by finding all the common factors starting from total by 2 to 1. So we find all the common factors and divide both the numerator and denominator if it's a common factor for both. So we'll arrive at an irreducible form. So later at last we'll be printing the irreducible form separated by a comma. That is, if we get NP equal to 2 and total equal to 5, our output should be 2 by 5. This is done by this program. And that's it. Thank you.